Hey guys, we're gonna do another video for homework for 1 through for 3. The function t equals f of s, stupid name, but whatever, models the time in hours for a sample of water to evaporate as a function of size s of the sample measured in milliliters. What are the units for f double prime of f? So units for f of s is, we're talking about size. So this right here, f is a function of size in milliliters. Okay, so this is going to be equal to milliliters. And t is the, so if we had a graph right here, the y value, so the value on the y-axis would be f of s, which would be milliliters, and this would be time, which is in hours, so this would be hours. That is so dumb. Why would you pick t whenever you're measuring it in hours? So they're saying here is t, but this is hours. So t, which is equal to f of s, would be the y-axis. This would be hours. That's stupid. You don't use t for the y. You just never do. It's either... That's just dumb. Sorry. That's just stupid. But whatever. Okay. So f prime of s, the units here are going to be the units of the y, milliliters, over units of the x, which are going to be hours. So this is going to be milliliters per hour. Okay. Hold up. The function t, f of s, models the time in hours. The flip, so there, wait a minute. So this t is hour, this is hours, which is equal to f of s. S is the x-axis, which is equal to size. So I'm getting this backwards right here. That's even more stupid. Okay, so that means right here, the function is a model for time in hours. So this is hours. This is hours per milliliter. And that means the double prime of s is going to be equal to, so again, so if we had an axis right here, so we're saying that this is hours, and hours is equal to t, which is equal to f of s. S is the variable, is the x variable, and s is equal to the size in milliliters. Okay, yeah, no, that's lining up, but I don't like that. So this would be hours per milliliter per milliliter. Yep. So hours per milliliter per milliliter. It's going to be C. Okay. Fair enough. So the function C gives the production cost for a bakery to produce cakes of a certain type, where C of x is the cost. Okay, so this is y. C of x is the cost. So C of x is going to be equal to the cost. Okay, in dollars to produce X number of cakes. And X is the number of cakes. So if I had an axis right here, this would be cost, and this would be cakes. Number of cakes. Okay, the function m defined by m of x is equal to here gives the marginal cost in dollars. Marginal cost, by the way, so marginal cost is, you could say marginal cost is pretty much the derivative of, we'll say this right here, marginal cost is equal to c prime of x. Okay? Marginal cost is c prime of x. Okay, so c prime of x is going to be equal to cost per cakes. Okay, it gives the marginal cost in dollars to produce cake number x plus 1. Changing which of the following best gives the estimate for the marginal cost in dollars to produce the 40th cake? Okay. To produce the 40th cake. Gives the best estimate for the marginal cost in dollars to produce the 40th cake. The best estimate. Okay, so we're looking at here, c of 39 over 39 would be the number of cakes divided by 39. This would be like an average cost, so no. This is c of 40 minus c of 39 over 40 minus 39. I think they're trying to bait you guys into picking this one since this looks like it's average rate of change, but it's not average rate of change. That would be c of 40 minus c of 39 over 40 minus 39. These are not equivalent at all. These are not equivalent. Not equal to each other. So that would mean c prime of 39, yeah. C prime of 39 would have to be the answer. It's not going to be this right here. This gives you the difference between c prime. So no, it's not going to be this one right here. Okay, so yeah. It's got to be c prime of 39 to produce the 40th cake. Marginal cost, which of the following best gives the estimate for marginal cost. C prime is used to represent marginal cost. So c prime of 39 would give us the best estimate at the 40th cake. Yeah. Okay. Cool. Let's move on. So this one is having us use a calculator. So the function d defined above models the depth in feet of the water t hours after 12 a.m. in a certain harbor. Which of the following presents the method for finding instantaneous rate of change of the depth in water in feet per hour at 6 a.m.? So the function d define. You don't even need the calculator here. Why would they say this? Because you don't even need a calculator here if you're just trying to see which is the best method. You would use a calculator, whatever method that you're using, but we're just picking the method, so you don't actually need a calculator here. So the function d defined above gives the models, so depth in feet. Okay, which of the following, for finding the instantaneous rate of change, which of the following presents the method for finding the instantaneous rate of change for the depth of the water in feet per hour at 6 a.m. So let's see here. So d is basically, so d of t is depth. In feet. D prime of t would be equal to depth per, it will be, the units here are going to be equal to feet. And then what does t represent? Hours per hour. Okay. In feet per hour. So There you go. So in feet per hour, instantaneous rate of change. So if we're trying to find something, we need to be using d prime of t to get feet per hour. So we're not going to be using this right here because d of 6 will tell you the depth whenever after 6 hours. So d of 6 is the depth after 6 hours. So it's not going to be this one. D double prime would be equal to, so d double prime of t would be equal to feet per hour for every hour. So that is not what we're trying to find either. So it's not going to be that. So d prime of 6, this is average rate of change right here. So when the average rate of change, this would be an estimate right here. But yeah, so we want b then. So A is looking for what would finding the time when the average rate of change is equal to this right here. This is the instantaneous rate of change at 6 feet if it's equal to 0. So excuse me. So it's got to be B. All right, a particle moves along the x-axis so that at any time t is greater than 0, its position is given by this right here, where a is a positive constant. For what values of t is the particle moving to the right? Gotcha. Okay, so for what values of t is the particles moving to the right? So this means when the velocity v of t is greater than 0. So that's what we want to find. We want to find when v of t is equal to 0, and v of t is equal to x prime of t, the first derivative of position. So let's go ahead and find x prime of t. So x prime of t is equal to, so if I bring this down right here, so we're taking the derivative with respect to t, right? A is a constant. So t is the variable we're taking the derivative with respect to. So we're going to bring that 2 down. That becomes 2 over 2, a minus t to the first power times by -1 because that's the derivative of the inside. Okay, so then this just comes out to be negative a minus t, which I guess you can say is negative a plus t. So this right here, which is equal to v of t, so we want to take this, so we want negative a plus t, we need to set that greater than or equal to 0. That's whenever it's going to be moving to the right. So we'll add a to the other side. So when t is greater than, so when t is greater than this value right here, it's going to be moving to the right. Right? Yeah. Okay, so if that's the case then, so the particle is moving to the right only if between 0 and a. No. Okay. Particle moves along so that anytime t is greater than 0, the position. No, not between. No, definitely not that one right here, because this is saying a is t is less than a, but t needs to be greater than a. The particle is moving to the right only if a is less than t. So this is the same thing. So if I said a is less than t, these are equivalent statements. So a is less than t, so it's got to be b. It's not going to be c. Not whenever they're equal to each other. The particle is not moving to the right. That is also not the case. So it's got to be b. Okay, question 5. So a particle on the x-axis has a position x of t. So, okay. Now notice here that the function, this is velocity. And the units here are going to be, they don't give units here. Sweet. Okay, cool. Position over time. That's what the units here. Position over time. And this is time right here. Okay, the graph of the particle's velocity, v of t, is shown from 0 to 5 here. So this is the graph's velocity. Which of the following expression gives the total distance traveled? Okay, so if this is the velocity, understand here that since velocity here is positive, so you can say right here, so this is v of t, the y values here, they're greater than 0. So moving to the right. So moving right, and then here, this is when v of t is less than 0. We are moving left here. The particle is. Which of the following expression gives the total distance traveled? So gives the total distance traveled. So we would want to know the position from here. So the particle is moving to the right over here, and the particle is moving to the left over here. So we would want to know how far it traveled right and how far it traveled left right here. So how far did it travel right? So we would want the position. So if we had the position at t equals 3, that would be x of 3. And then if we subtract the position that it was at, so we would need x of 0. So x, we don't even need this graph right here, except for what's happening here. This is the part that's important right here. From 0 to 5, pretty much this is what's important right here. So if I take the position at 3, subtract the position where the particle is at 0 right here, this would give me distance, or it's like how much it moved to the right. And then if I want to find how much it moved left, well, I would need the position at 5, and I would need to subtract the position at 3. So this would give me the positioning at 5. This would give me the positioning at 3. If I take away if I subtract them, I'm going to find the total distance traveled, and this gives me the total distance traveled here. And then I would add them together to get my total distance. So that would have to be c right here. Yep. Okay. Sweet. An object moves along a straight line so that at any time t for 0 to 8, its position is given by this right here. For what value of t is the object at rest? So when the object is at rest, that means v of t is going to be equal to 0. So that's what we're going to look at to find. So we're going to need to find x prime of t, since that's going to be equal to v of t. That's going to be equal to the derivative of 5 is 0, derivative of 4t is 4, minus 2t. And so this is the velocity. We want to set that equal to 0, solve for t. So add 2t to the other side, divide by 2. T, when at time 2, what doesn't even say what units are here. Okay, so at t equals 2, though, that's whenever the particle will be at rest. Okay, all right, there you go. That's everything for this homework assignment.